Okay, I've gone ahead, gone back to the spreadsheet. When we left it originally, the spreadsheet was obviously much simpler. I'm going to go ahead and rebuild this for you, but this is kind of the way we left the spreadsheet first. We took the outputs of the 30 watt, copied that on, and the 30-degree angle one and the flat one, and pasted those on in here so they could be a comparison. And now I've gone and just taken and multiplied them by the number of panels and then done a couple of uh, steps with cost and payback. So if you look here, we took the panel output per any given month for a single panel, multiplied it by the number of panels to come up with the total output, and then we summed that all up. Then over here we took the cost of the panels installed, and this was taking the actual cost of the panel, which was $215. Typically a wholesale price is twice that to the consumer, but the idea here is that I picked a number that I thought would end up being what an installed cost would be. So I'm saying $500, a little more than doubling of the price, times the number of panels gives us a total cost. Then I take the energy cost, how much we're getting paid or paying for by the utility for our electricity, and then multiplied it by the total output to come up with this yearly amount of money that we're not paying for electricity, or the value of it. And then I took this number and divided it into 40 to figure out how long it would take to make a payback on that. And then in the last part, I took the amount of kilowatts per month, this data set over here, or it could be this one, but I use this data set just for it's just an order of magnitude different. Actually, I probably should have taken these. I'll do that in the next one when I go through it. And the idea is that you can see now how a panel that's tilted, the red ones, actually perform better towards the end of the season when the sun is low in the sky. So there's extra energy to be gained right here, and it really shows up in this chart. What's also remarkable, I guess, is that during the peak times, there's very little to be gained by tilting the surface. And this is in the Alfred location, and the project requires you to pick some other location, so your results will vary. So let's go now and rebuild this. So we have our two spreadsheets, data, tilted and flat, and now we're just going to basically kind of highlight them and color them so that we'll be able to decipher this. So I believe this one was done in blue, and I think this one was done in red. I'll go back and confirm that. Yep. And so our first step is, I'm going to pull this one back a little tighter. I'm going to rename this as panel output. That'll just shorten it a little bit, and it tells us that we're talking about one panel. And I'll just copy that and paste that down here also. And I'll stretch this out a little bit so it all fits within the thing. I can shorten up the number or the months here. We don't need that large a column for that. And then we have this idea of number of panels. And for the flat system, I meant this to be number. For the flat panels, we were able to get 80 into the system. So I'll just type that in once. I'll do Control C, and I'll do Control V for paste. Down here it was 64 panels, and I'll copy that and paste that down. And we can shrink this up a little bit. I need a label down there. It's just copying and pasting. And then we'll go total kilowatt hours. And that's going to be a calculation. I'm going to make this aligned to the, I don't like the way it looks there. I'm going to make it aligned to the right. Or excuse me, yeah. Control C, Control V. And this is just a formula, so we're going to do equals sum, start a parentheses, and it'll be this number, asterisk is times the panels, parentheses, and so that's the total of 80 panels of that output. So I'll do copy, and I'll do paste, and I'll do the same thing down here. So I might actually be able to copy the formulas. Let's see what I'll do here. C and oops. And let's just double check that any of these formulas is right. So I copied this one. It's D24 times F24. We're in row 24, so it's D times F. That's right. I'll just double check down here again. And that's 30. So that's all working out fine. Let's get a total for this now. So this is another formula. And that's equals sum of an array of a list, a range. And I'll do the same thing down here again. So there's our total outputs. Let's see if those compare. 25, 178, yes they do. So let's go ahead now and just copy these terms, and then we'll actually do the formula work in the other one. So I'm going to go ahead and paste that in here. And I didn't bring my blues over far enough, so let me just do that right away. And we'll stretch this out, shrink this back a little bit. Let's tighten this up a little more. Okay, so cost of panels installed. As I said, I'm going to estimate $500, which is a little more than doubling it, times the 80 panels. So our total cost, and actually I'll make this a currency symbol, and I'll make our total cost equal to the sum of this number times that number. That's our total installed system cost. Our energy cost, I've estimated at 14 cents a kilowatt hour. I looked up some electrical rates just by going electricity rates, 13 point something. We're actually higher than that in New York State, but you could research this a little more if you want a tighter number. So I put in 14 cents. So the total electricity generated, I'd rather change that to let me just double click into that, and I'll change this total electricity dollars, because that's going to be a formula of equals again sum of the total amount of kilowatt hours times the cost per kilowatt hour, and that gives us another number that we'll make into a currency. So that's how much money we generate every year. And then this idea of simple payback is nothing more than taking the total cost of the system and dividing in how much we save in a year to see how long it takes us to pay back. And it's simple payback because there's no interest involved. It's a relatively simplistic look at a payback period. So we'll do that as a formula, equals sum, and we'll take the total cost of the system divided by the amount that we get every year, and that gives us a payback period. And let's just reduce this down so it looks cleaner. I don't know how we adjust our decimal points. I'll just click back this way, I guess, and it'll just round it. So we can go 10.3. That's a nice rounding. And so we can actually take this now probably and just copy that and paste it here. And we want to change a few things. We want this to be $400, and we want to have 64 panels. Oops, not 400. It's going to cost us more, 600, because they're going to be tilted, so we have to have some kind of framework. We still have that value is the same. And our cost, our total electricity, let's just make sure the formula is right. It's G32 times J23. J23, so that's correct. And our simple payback is also J22 divided by J24. So that's our comparison of payback, and looks pretty good. So let's now try to make a view of the outputs, the power outputs of the panels. And I'm going to do it, I was going to do it with the total total output multiplied by the number of panels. But let's just look at a single panel per month. And so I highlighted a range, asked it to make a chart, and we want the chart to actually be a stacked area chart. It's starting at the first month, so I don't like the way it's starting at the second month. So I'm going to just delete this one, and I'm going to try to do this range differently. I'm going to go over this whole area here. Click on that, and there we get the other starting point, and it's starting at about 15 or 14, and it looks like it's working properly, except that we do want it to be a bar chart. So let's just move that over, and it nicely labels it kilowatt output versus month. It's labeled everything for us, and now we want to just try to add another range to it. So I'm going to go add another range, and I'll pull this range in and click OK, and it doesn't look like it came out all the way to the 12 months, so I'm going to undo that, and I'll try to do this one more time. Add another range, and I'll grab all of those the same way I did the other one, and there, that looks better. But what they're doing is they're additively aggregating them. So instead of it being a standard stacking, let's see if we say none. So there's no stacking. I don't understand why we're shortened on our range here, though. That really disturbs me. We had such a nice, we're missing one data point towards this end here. So let's go through and try this one more time. I'm going to grab this whole thing. And let's go ahead and try to add another range. And let's do this exact same way. And they seem to be better that way. And now the only problem we need to do is change it so that there's no stacking involved. And we still have this other piece of data that comes in here, this red thing, the month. So let's see if we can fix that. I'm going to double click on this. Look at these data ranges. That's okay. It's this month thing. Let's see if we delete this. Yeah, there we go. It looks like we're good now. Now I noticed you could do a couple of things with this. You can actually shrink this down and make it a little more compact. Move it out like that. But I think that's a good start for our comparison. So like I said, this idea of the space between these two of the performances, with the idea that they have one has a tilt and one doesn't have a tilt. I like to see something in your narrative or your write-up on the presentation that kind of reflects your analysis of this. The idea that even though we use a tilt and less panels, we're getting almost the same amount of power out of the system, but we have the extra cost of this installed cost of the of tilting the panels. So there's a lot of things to consider in the evaluation of these systems. I'm going to also go ahead and create a little background for these so they maybe read a little better. That's ugly. Wrong gray, I think. Let's try that one. Okay, so there I think we're pretty well set. Now we're going to look next at how we can tilt the actual roof and keep flat panels on it and probably get the best performance out of our system. But that means we're going to have to make an architectural intervention, and we'll deal with that next.